Good evening, all of you. So today we are going to see some basic concepts in chemistry. So along with that, we'll see redox reactions also, right? So both will finish today. Okay. So in this chapter, we are going to discuss first part in this chapter is concentration terms. Okay. So in concentration terms, Jayashri, can you keep your audio mute? In that first one, physical methods. Okay, so physical methods means mass percentage, right? That is weight by weight. So weight by weight percentage is given by mass of solute by mass of solution. Mass of solution into 100. So always remember that, easy to remember, the numerator part. Now if you consider this numerator part here, this numerator part represents a solute. This denominator part always represents a solution. That is how it is easy for you to remember. In both the cases, weight by weight. So we are considering only mass. Next one, volume percentage. Volume percentage is V by V. So what will be the formula for this? Numerator represents a solute. So this is a volume of solute by volume of solution into 100. So like that, you can remember it easily. Next one. Weight by volume percentage. It is given by weight means a numerator. Numerator represents a solute. Weight of solute by volume of solution into 100. Last one. Parts per million. This last one, parts per million. ppm. So what ppm will give? Mass of solute by mass of solution into 10 power 6. So this is all about physical methods, concentration terms, but these are all physical methods, right? So next, chemical methods. We'll move to chemical methods now. So what are those chemical methods? First one, molarity. This is represented by capital letter M. So molarity is given by number of moles of solute by volume of solution in liters. Okay, this is number of moles of solute. Our full form, weight of solute by molecular weight of solute into 1000 by volume of solution in milliliters. Okay, so now molarity is inversely proportional to temperature. That means as molarity increases, as temperature increases, molarity decreases. So it is temperature dependent. And what is unit of molarity? Moles per liter. Okay, moles per liter. Similarly, molarity is given by X into density into 10 by molecular weight of solute, or X into specific gravity into 10 by molecular weight of solute. Then what is X? So where X is weight by weight percent. Then M1 V1 is equal to M2 V2. So this is for same solutes. For different solutes, M1 V1 by N1 is equal to M2 V2 by N2. N1 and N2 are number of moles. Okay. Then you want to find volume of H2O. Volume of H2O to be added to change a condensation, to change the concentration from M1 to M2. So that is higher concentration minus lower concentration by lower concentration into volume of solution. Volume of solution. So this is volume of H2O. This is volume of H2O. Did you understand? So this is about molarity. This is all about molarity. Then normality. What is normality? Normality is given by number of gram equivalents of solute by volume of solution in liters. Number of gram equivalents of solute by volume of solution in liters. So this is normality. This is about normality. Then full form of normality. Weight of solute by gram equivalent weight of solute into 1000 by volume in milliliters, into 1000 by volume in milliliters, or normality is given by X into density into 10 by gram equivalent weight of solute. Again, here also same x is equal to weight by weight percent, right? Then similarly, law of neutralization, N1 V1 is equal to N2 V2, or if mixture of acids and bases, then resultant normality is given by normality of acid into volume of acid minus normality of base into volume of base by volume of acid plus volume of base. Okay. Now, what is equivalent weight? How to calculate equivalent weight? So let us consider equivalent weight of acid. It is given by molar mass of acid by basicity. What is basicity? Number of replaceable H plus ions. So example, equivalent weight of HCl. What is its molar mass? 36.5. Number of replaceable hydrogens. You can see there is only one, so it will be 36.5. Equivalent weight of HNO3. 63. Number of hydrogens. 1. Equivalent weight of H2SO4. Then what you will get? Molar mass 98. Number of replaceable hydrogens 2. That is 49. Equivalent weight of phosphoric acid. So that is 98 again. That is also 98. Number of replaceable hydrogens 3. Equivalent weight of phosphorus acid. But here replaceable hydrogens are, I think it is 82 by 2. How you can determine that? P double bond O, OH, OH, H. So hydrogens attached directly to oxygen are considered as replaceable hydrogens. Replaceable hydrogens. This is how we will calculate equivalent weights of acids. Then let us move to equivalent weights of bases. That is given by molar mass of base by acidity. So what is acidity, sir? Number of replaceable OH minus ions. That is what we call acidity. Did you understand? So this is about acidity. Next, examples. Equivalent weight of NaOH. It is a base. So that is 40 by number of OH minus ions, 1. So it will be again 2, 40. Equivalent weight of calcium hydroxide. What it will be? Calcium 40, 2 into 16, 32 plus 2. What it is? 74. But how many OH minus ions are there? 2. So that means 37. So this is how you will calculate equivalent weight of base. Then equivalent weight of salt. Molar mass of salt by total charge on cation or anion. Total charge on cation or anion. So what is it? So let us see. Equivalent weight of NaCl. And we will get NaCl 58.5. The total charge on cation and anion, that is 1. So that is 58.5. Next, equivalent weight of consider Al2SO4 taken thrice. It is 342. Check it once. and total charge 2Al plus 3, 3SO4 minus 2. So this is plus 6, this is minus 6. In either cases, it is 6. Okay. So that is about equivalent weight of Al2SO4 taken thrice. Okay. This is how you calculate equivalent weights of salts, right? So let us move to molality. Next concentration term, molality. So that is small letter m. So molality is given by number of moles of solute by weight of solvent, sir. It is not solution, solvent in kg. Then full form of molality. Let us see full form of molality. So molality is given by weight of solute by molecular weight of solute into 1000 by weight of solvent in grams. Weight of solvent in grams, right? So this is formula for molality. Now molality is independent of temperature. Independent of temperature. Then what is units? Moles per kg. I just get back to that normality once again because I will give you temperature dependence, right? So normality is inversely proportional to temperature. And what is unit, sir? Equivalence per liter, gram equivalence per liter. So this is about temperature dependence, and this is about unit of normality, right? Now we'll get back to our topic. This is about molality. Next, mole fraction. So mole fraction, let us suppose consider a binary solution. What is binary solution? Which is having two components. Binary means two. So two components. That means A and B. Let us suppose if you want to consider mole fraction of A, then number of moles of A by number of moles of A plus number of moles of B. Similarly, if you want to find out mole fraction of B, number of moles of B by number of moles of A plus number of moles of B. But always mole fraction in A, mole fraction of all the components present in a solution should be equal to 1. So this is also temperature dependent and it has no unit because both numerator and denominator has moles only. So moles gets cancelled and it is having no unit, right? This is about mole fraction and mole fraction.
Excuse me, sir.
Yeah. Tell me.
Could you please retake the screen that mole fraction?
This one.
Sir. Sir, ಅಲ್ಲಿ equivalent of aluminum sulfate ಇದೆಯಲ್ಲ sir?
What is your doubt there? How to calculate?
Equivalent of aluminum sulfate is there, no?
Yes.
Then we can write it 57 directly. We can cancel it, no, sir?
What 57? 342 by 6, sir?
Sir.
Yeah, that I left it to you. Okay.
Okay, sir.
I left it to you. No problem. You can cancel it. That's it, Jayashree.
Sir.
Yeah, you can. I just left to students. 342 by 6 means whatever it is.
Yes, sir.
Okay.
Thank you, sir.
Yeah, no problem. Yeah. Small fraction of solute is given by, in terms of molality, sir. Molality by molality plus 55.55. So this is shortcut method to determine mole fraction of solute. If molality is given. If molality is given. So this is about concentration terms, right? So then redox reactions. Redox reactions. What are redox reactions? So both oxidation as well as reduction takes place simultaneously. Okay, let us suppose zinc plus Cu plus 2 gives rise to Zn plus 2 plus Cu. Now zinc is converted into Zn plus 2. So 0, 2 plus 2. Is there increase in oxidation state or not? Yes. So that is what we call increase in oxidation state is called oxidation. Now here copper plus 2, 2, here elemental form 0. That means the oxidation state is decrease. Decrease in oxidation state is called reduction. Decrease in oxidation state is called reduction. So such a reaction is called redox reaction. Then how to identify oxidation states? Let us suppose hydrogen. Hydrogen oxidation state is generally +1. But in metal hydrides, like when it is combining with sodium, so sodium hydride, then hydrogen oxidation state will be -1. So in metal hydrides, hydrogen exhibit -1, and in its general oxidation state, it is +1. Okay, now let us suppose if it is present in its elemental form, then what is oxidation state? 0. So when any element is present in its elemental form, then the corresponding oxidation state will become 0. So this is about hydrogen. Now let us suppose oxygen, common oxidation state is -2. But in peroxides, it exhibits -1, like H2O2. In superoxides, it is -1/2. Example, KO2. Okay. With fluorine, OF2. So oxygen exhibits +2. O2F2. Oxygen exhibits +1. So these are some special cases of oxygen, right? Because you need to, like, you will get some questions based on balancing redox reactions, So then you need to find out oxidation states also, right? So now we'll move to questions part now, because this is completely numerical based chapter, right? So let us solve some questions, then you will understand what type of questions you will get, right? So mostly some basic concepts of chemistry, you will get questions based on mole concept. Questions based on mole concept. Then what type of questions you will get? Okay. So let us discuss some questions. Today's first question. An oxide of metal have 20% oxygen. 20% oxygen. Then the equivalent weight of oxide is and the equivalent weight of oxide is. Options given are 32, 48, and last one 52. Okay. Now let us proceed with this question. An oxide of metal, we don't know what is that metal, but it's oxide. at 20% oxygen. Let us start from that point, 20% oxygen here. What does that mean in percentage? Let us suppose 20 grams of oxygen means remaining out of 100, 20 grams is oxygen means remaining 80 grams will be metal. You understand here 20% oxygen is present means remaining 80% what it is? It should be metal. So we are taking in terms of grams. 20 grams of oxygen means remaining 80 grams of metal should be present. Then what is equivalent weight of oxygen? So how to calculate equivalent weight? Oxygen. Equivalent weight of oxygen is its atomic weight by valency. What is atomic weight of oxygen? 16. Valency oxygen 2. So that is 8. So 8 grams of oxygen contains 20 grams is present in 80 grams. Then 8 grams will be present in, so cross multiplication, 80 by 20, this you bring it here, into 8. 0, 0 gets cancelled. 64, 2 in 8, 4 times 8 fours, 32 grams. Okay, so that means metal is 32 grams, oxygen is 40 grams, right? Then what is question? Equivalent weight of oxide. So therefore, equivalent weight of that oxide. Oxygen is 8, metal is 32. Total equivalent weight of that oxide will be 40 grams. So which option is correct, sir? Second option. Which option is correct? Second option. Then next question. Shall we proceed?
Yes, sir.
Given that the abundances of isotopes isotopes, iron 54, next iron 56. What is isotope, sir? Species having same atomic number but different mass numbers. And iron 57 are their percentage abundance 5%, then 90% and 5% respectively. Okay. Now the atomic mass of iron is, the question is, we need to find out the atomic mass of iron. So average atomic mass. How you will find out average atomic mass? Sigma of percentage of abundance into mass number divided by total ratio or percentage. Total percent 5 plus 90 plus 5%. So that will be 100. So, but what is percentage abundance into mass number? So these are mass numbers. So 54. What is its corresponding percentage, sir? Its corresponding percentage is 5. Then 56 into 90. Then 57. What is it? This is 57. So 57 into, where is this? Sorry, 5%. Here. That you have to take algebraic sum. How? Let me see. So average atomic mass is first one, 56 into 5%, right? So this is 56 into 5%. Plus next one, 56 into 90%. Sorry, this is, what is first one?
54.
54. Yeah, sorry. This is 54. Next, 56 into 90, isn't it? Next, 57 into 5. Total ratio, 5%, 90%, 5%. Can you add, multiply and add and divide? Can you tell me what is your answer? This is divided by 100. 54 into 5 plus 56 into 90 plus 57 into 5. So just tell me what is that average you are getting. That will be average atomic mass of iron. Did you understand?
Hmm.
A simple multiplication and division, nothing more than that.
55.95, sir.
55.95, huh?
Yes, sir.
Okay. 50. So 55.95. So everybody got this answer or not?
Sir. Yes, sir.
Okay. So that is how you should find out average atomic mass. Did you understand how to find?
Yes, sir.
Okay. Then shall we proceed for next question? Number of atoms. I'm moving to the next question. Number of atoms in five 558. Sorry, 558. 5 grams of iron is. So here one hint is given, that is atomic weight is, I mean that is 50. Sorry, lost connection. What is that question? You need to find out number of atoms in 558.5 grams iron. In this, atomic weight is given 55.85. What are options? First option is twice that in 60 grams carbon. Next, 6.023 into 10 power 22. Next, half in 8 grams helium. Next, 558.5 into 6.023 into 10 power 23. So these are the options given. Now how to solve this question? Okay, now find out number of atoms in 558.5 grams iron. Okay, so now for our convenience, I am finding here number of moles of iron. So number of moles of iron. How you will get number of moles of any substance? Weight by gram molecular weight. What is weight given there? 558.5 grams by gram molecular weight or atomic mass. What is that? 55.85. That means how many times? 10 times. So how many moles of iron is given in the question? 10 moles. Now, which is equal to 10 moles in the given options? In that, we'll go one by one. Twice that in 60 grams of carbon. So let us find out number of carbon, number of moles of carbon again. If both are same, means answer will be first option. How you'll get again number of moles? Same formula, sir. Can you see there? Weight by gram molecular weight. What is weight? 60 given. What is atomic mass of carbon? 12. What is that? 5 moles. So 5 moles means exactly half of 10 moles. That means so a number of atoms in 558.5 grams of iron is twice that in 60 grams of carbon. Here, number of moles of iron is exactly twice that of carbon. Twice that of carbon. So first option itself. Next question. So write down question. A certain compound compound has the molecular formula X4O6. X4O6. This is molecular formula of the compound. If 10 grams of compound contain 6.06 grams of X, then the atomic mass of X is, A, 32 atomic mass units, B, 37 atomic mass units, C, 42 atomic mass units, D, 48 atomic mass units. So how to solve such questions? Molecular formula is given. Only 10 grams of compound contains 6.06 grams of X. Now, based on this, now In the given compound, how many X atoms are present, sir? 4X. How many X atoms are present? 4. Then, what is total molecular mass of X4O6? We don't know what is molecular mass of X4O6, but 4 into X plus 6 oxygens. Oxygen we know that 16. 16 into 6, that is 96, is equal to. Now, mass of X is given. Out of 10 grams of the compound, total mass of the compound, it is taken 10. Then mass of 4X, how much it is? 6.06. Then what is in it? Atomic mass of X. Here, if you find X, then that will be your answer. So what it is? Cross multiply. 4X into 10 is equal to 4X plus 96 into 96. 4X plus 96 into 6.06. What you are getting? 40X is equal to 4X into 0.6. What you are getting there? Can you multiply?
Sir, 24.24.
24.24, sir.
24.24.
Sir.
So that means 24.24X, isn't it? Plus 96 into 6.06.
581.76. 581.76, sir.
581.76. Okay. Now keep it this here. Bring it here. 40x minus 24.24x is equal to 581.76. Now do it. 40x minus.
Sir, 16.24.
16.24. Check it once again.
Sir, 15.76.
15.76 x equal to 581.76. Then x is equal to 581.76 by 15.76. Now do it. 581.76 divided by 15.76. What you are getting?
36.91, sir.
36.91. So all of you got it. 36.791 means round it off. What it will be? 37. Do we have 37 option or not? Where is it? Second option. 37 AMU, atomic mass units, right? Did you understand?
Yes, sir.
Okay. Then we'll proceed with one more problem. These are all based on mole concepts. Next question. Yeah. Okay, write down. Next question. When some amount of zinc is treated separately with excess of sulfuric acid, with excess of sulfuric acid and excess of NaOH, sodium hydroxide. The ratio of volumes of hydrogen evolved. So in which ratio hydrogen gas is evolved? In two different cases. One is zinc treated with H2SO4 and zinc treated with NaOH. That means zinc is treated with acid and zinc is treated with base. Then what will be the ratio of volumes of hydrogen evolved? First option 1:1, 1:2, 2:1, last one 3:1. Okay, how to find out? First write down what is that reaction between zinc and H2SO4. So zinc can displace H2, then what you will get? Zinc sulfate plus H2. Next one, zinc plus NaOH. So I'm writing balanced equation now. Na2ZnO2. Sodium zincate plus H2. In both the cases, what is the ratio? Here 1 mole, here also 1 mole. So what is that ratio? 1:1 ratio. What is the ratio of volumes of H2 evolved? In both the cases, it is 1 mole only, right? But to answer this question, you should be able to write that balanced equation for zinc with sulfuric acid and zinc with sodium hydroxide. Done. Shall we proceed for next question then? Okay. Hmm. 27 grams of aluminum will react completely. Completely with how many grams of oxygen? With how many grams of oxygen? Options given are 8 grams, 16 grams, 32 grams, 24 grams. Okay. So how to find out? So here aluminum and oxygen. So they have different valencies. When they are different valencies, always 1 gram equivalent of aluminum will react with 1 gram equivalent of oxygen. What is equivalent weight of aluminum? Formula: if atomic weight by valency. Here also oxygen already we did it in this session. Once again, I'm just reminding you atomic weight of oxygen by valency. What is atomic weight of aluminum? 27 by valency is 3. So that is 9 grams of aluminum. Okay. Completely react with the atomic weight of oxygen. 16 by 2. That is 8 grams. So 9 grams of aluminum completely reacts with 8 grams of oxygen. 8 grams of oxygen. Now this is the relationship. This is the relationship, right? 9 grams of aluminum gives 8 grams of oxygen. So in this case, how we can calculate for 27 grams. 9 grams of aluminum reacts completely with 8 grams of oxygen. But the question is about 27 grams of aluminum completely reacts. That means 8 by 9 cross multiplication, sir. 8 by 9 into 27. 3 times 8, 3 is 24 grams of oxygen. So 27 grams of aluminum will completely react with 24 grams of oxygen. So which option is there? Fourth option. Right. This is one more question. Next, shall we proceed for next question? Next question. Calculate the weight of line. Calculate the weight of line. What is line? CaO. Obtained by heating. Obtained by heating 200 kg of 95% pure limestone. 95% pure limestone. That is calcium carbonate. Options given are 104.4 kg, 105.4 kg, third one 212.8 kg, fourth one 106.4 kg. So these are 4 different options given. Now let us check how to answer this question, right? Now calculate the weight of lime obtained by heating 200 kg of 95% pure limestone. So what happens if you heat pure limestone? Limestone is CaCO3, which upon heating gives CaO plus CO2. Now this is the equation. So what is the molar mass of CaCO3? 100 grams. 100 grams of CaCO3 gives Ca 40 plus 16. 56 grams of CaO. But for how many kg we need? 200 kg. But what is the percentage of pure? 95%. That means 95% of 200. So this is in 2 times 2 into 95, 190 kg. That means actually it is 190 kg only, right? So 100 grams gives 56 grams. That means convert into kg. 100 kg of calcium carbonate gives 56 kg of CaO. Then 190 kg of calcium carbonate gives, that means 56 by 100 into 190. 0, 0 gets cancelled. 10 in 56, 5.6. So 5.6 into 19. So calculate. What is that? 5.6 into 19. What you are getting?
106.4, sir.
Not 6.4 grams. Sorry, kg, right? Not 6.4 kg. Right? So this is another model. Done. Following or no? Shall we proceed for one more question?
Yes, sir.
What is the weight of 3.01 into 10 power 23 molecules of ammonia? Options: 17 grams, 8.5 grams, 30 none. What is the weight of 3.01 into 10 power 23 molecules of ammonia, right? So generally, according to mole concept, 1 mole of any substance, let us suppose here it is ammonia. 1 mole of ammonia contains Avogadro number of molecules. What is Avogadro number of molecules? 6.023 into 10 power 23. That means 6.023 into 10 power 23 ammonia molecules is equal to 1 mole. But for how many molecules we need to find out weight? 3.1 into 10 power 23. So 6.023 into 10 power 23 molecules means 1 mole of ammonia. What is molar mass of ammonia? 17 grams. So these many molecules weighs 17 grams, then 3.01 into 10 power 23 molecules. Exactly half. Exactly half. That means 17 by 2. What is that? 8.5 grams. Where is this? Here. Simple, isn't it?
Yes, sir.
Okay, shall we proceed for next question then?
Yes, sir.
So tell me, how many carbon atoms are present? Next question. How many carbon atoms are present in 0.35 mole of 0.35 mole of C6H12O6. C6H12O6. You need to find out how many carbon atoms are present. Options are 6.023 into 10 power 23 carbon atoms. Second option, 1.26 into 10 power 23 carbon atoms. Third option, 1.26 into 10 power 24 carbon atoms. The last option is 6.023 into 10 power 24 carbon atoms. So these are options given. These are options given. So how many carbon atoms are present in 0.35 moles of glucose? Right. So let us start with glucose only. Right, to take any confusion here. So let us start with glucose. 1 mole of glucose, isn't it? That is C6H12O6. This is 1 mole, right? In this, how many moles of carbon atoms are present? How many moles of carbon atoms are present? Here, 6. 6 moles of carbon. 1 mole contains 6 moles. But how many moles of glucose is taken? 0.35 moles of C6, H12O6 contain. How many? 6 by 0.35. So what will be your, 6 by 1 into, this is wrong. 6 by 1 cross multiplication, right? 6 by 1 into 0.35. So how many moles it will become? 6 into 0.35.
2.1, sir.
2.1. 2.1. But what we need actually, do we need in moles or number of atoms?
Number of atoms.
So multiply with Avogadro's number so that you'll get number of atoms. Here, don't write here. Number of carbon atoms, that is 6 into 0.35 into Avogadro number. So that is 6 into 0.35 into 6.023 into 10 power 23. So now multiply all those values and let me know what is your final answer.
12.64 into 10 to the power of 23, sir.
1.64.
64.
10 to the power
23.
1.26, isn't it? This is what you are saying, right? Into
12.64, sir.
12.64.
Yes, sir.
So, what's your name?
Barish.
Okay, Bairesh is saying 12 point. What is that, boy?
6483.
64 into 10 power
23.
23. Do you have that option?
No, sir.
No, sir.
That you convert decimal. This 2, you bring it here. One
One
decimal.
point-
So what it will become?
1.26
1.26.
into 10 to the power of 23. 24.
24. So this is your answer. Which option?
Option 3, sir.
Done.
Yes, sir.
Okay, then we'll move to next problem then. Write down. Next question. Which one of the following pairs, this is one frequently asking question. Which one of the following pairs of gases contains the same number of molecules? The same number of molecules. Options given are 16 grams of O2 and 14 grams of N2. Next, 8 grams of O2 and 22 grams of CO2. Third option, 28 grams of N2 and 22 grams of CO2. Fourth option, 32 grams of O2 and 32 grams of N2. These are the options given. Same number of molecules means same number of moles. Okay, if number of moles of all those gases are same, then they'll have same number of molecules. First option. What is formula? Number of moles, weight by gram molecular weight. What is weight of oxygen? 16. Gram molecular weight of oxygen, that is 1/2. Next, 14 grams of N2. Number of moles. Weight by gram molecular weight, N2, 28. How many times? 2 times. So both are having same number of moles. Both are having same number of moles, right? So first option itself. Done. Shall we move to next model?
Yes, sir.
Two solutions. It's completely different model. Of a substance are mixed in the following manner. In the following manner. What is that? 480 ml of 1.5 molar of first solution with 520 ml of 1.2 molar of second solution. Then the molarity of final solution is, options given are 1.2 molar, 1.5 molar, 1.344 molar, 2.7 molar. Two solutions are mixed together. Then molarity of resultant solution. What is formula? M1V1 plus M2V2 by V1 plus V2. What is M1V1? Here. 1.5 into 480 plus M2V2. 1.2 into 520. Total volume 480 by 520. Calculate and let me know. 480 by 520. What is that? 1000.
Sir, 1344, sir.
1344, 1.344, right?
Sir.
That means 1344. And you get 1.344. Shall we proceed for next question then?
Yes, sir.
It's an aqueous solution of 6.3 grams oxalic acid dihydrate is made up to 250 ml. That means 6.3 grams of oxalic acid is dissolved in 250 ml of water. Then the volume of 0.1 normal NaOH required to completely neutralize. To completely neutralize 10 ml of this solution is. Okay. That means how many milli-equivalents of oxalic acid required to neutralize how many milli-equivalents weight of NaOH. Okay. So first, this is the relationships are actually milli-equivalents. This is how you should proceed. Milli-equivalents. Neutralization means milli-equivalents of acid should be equal to milliequivalents of base. What is the base? NaOH. Right. So what is milliequivalence means? Normality of acid into volume of acid is equal to normality of base into volume of base. Do you have normality of oxalic acid? We don't know. Then first normality of acid, weight by equivalent weight. What is weight given there, sir? 6.3. Oxalic acid. This is actually oxalic acid. CS3COOH dihydrate 2H2O. So that is 126 grams molar mass. Then equivalent weight of oxalic acid is equal to, what is formula? Molar mass by basicity. What is basicity? Number of replaceable hydrogens. In this case, how many replaceable hydrogens are there? This is 1, this is 2. What is that molar mass? What is that molar mass? 126 already we got. How many replaceable hydrogens? 2. So that is 63. So equivalent weight is 63. Now I am substituting here. In 2000 by, what is volume of solution in ml? 250. So 250 means 4 times. 6.3 in 63, 10 times. 4 by 10, that is 0.4. So now we found the normality of acid. Now substitute here. Therefore, NaVa is equal to NbVb. What is normality of acid here? 0.4. Volume of acid, 10 ml of this solution. That means acid. 10. Normality of base, it is given there, 0.1. And what is volume of NaOH required? This we need to find out. 0.4, 4 times. 4 into 10, 40 ml. So how much volume of base is required, sir? 40 ml of base is required. So this is about volume of base. This is about volume of base, right? So these are how you will get questions based on mole concept and concentration terms. Regarding redox reactions, we'll discuss those models tomorrow, right? In this session, we completed questions based on some basic concepts in chemistry. Remaining we'll discuss tomorrow, right? So meet you tomorrow then. Good night, all of you.
Bye, sir.
Bye-bye.